In this class, we are going to study about the minimum and maximum bone conduction masking noise. So here, we'll take this audiogram. If you take this audiogram, in this audiogram, if you see, do you need a masking for 250 Hz? Right, left in this? Both the ACs are equal. Gap is more, looks like conductive component. We will not take this. Although AB gap more than 15 decibels. Then we go to 500 Hz, 10 decibel gap. Do we do masking? No. Then we go to 1 kilohertz. The gap between the non-test here is anyways 5 decibel, but the AB gap of the test here is how much? Core here is 10 and 20. Do you require masking? Yes. So AB gap is more than equal to 15 decibels, so you need masking. So we'll take example of 1 kilohertz. So now let's take the example. Then we have to find out the minimum and the maximum amount of noise required. So you do the BC test setup. In the BC test setup, which ear BC is to be found now? Left ear. Left ear. So this is the left ear because left is the poorer ear. So I place my BC vibrator where? Here. This is my BC vibe on my left ear and the headband comes here. Correct? Now I have to give the noise. So for the noise I place the AC vibrator where? AC headphones where? Right ear. To my right ear. So this is my right ear. Done. So now I have to give a minimum amount of masking noise and a maximum. In between I will find a threshold by Platy method. In this class we are understanding the minimum amount of noise. Theoretically or by understanding, the minimum amount of noise would be till what? You have to say stop when the noise is enough. Stop. Again. Which means the noise should be just sufficient to mask this cochlea. So in this particular setup, when you are giving a BC tone, then what happens? This BC tone reaches both the cochleas, right? So now what we are doing? This noise should be just enough to mask the cochlea. So what should be the amount of noise? Just because it is just enough to mask the cochlea, this is AC of the which ear? Non-test ear. Very clear? But the moment we give the BC tone here, as the ear is occluded, the tone due to middle ear outflow theory goes, returns back into this. Correct? So as it returns back into this cochlea, there is a increase in the sound pressure level due to occlusion effect. For 1 kilohertz, the occlusion effect is how much? 10 dB. That means there will be a pseudo increase in 10 decibel of the threshold of the BC of the non-test ear. So what we do? We have to increase the noise also accordingly. So what do we do? AC non-test ear plus occlusion effect. And third, there is a variation of plus minus 10 decibel inter-subject variability. So as a safety factor, we put 10 decibel so that the noise just masks this cochlea. It should not be less also. Understood? So this should be the formula. AC non-test ear plus occlusion effect plus 10 decibel. Clear? So in this case, if you see, what is the AC non-test ear for 1 kilohertz? How much? 25 decibels. Plus occlusion effect in 1 kilohertz is 10 decibel plus 10 decibel. So the amount of minimum masking noise is 25 plus 10, 35 plus 10, 45 decibel. 45 dB what? EML. Okay. Then comes the maximum masking noise. You have to say stop when the maximum masking noise reaches. So from here the noise has to be there. What? Stop till here? No, it should be just insufficient to reach the other ear. It should not be reaching the other ear, remember. So again now. Stop. Yes. Stop. So technically the maximum masking noise should be this much, and the amount of noise to reach from this ear through the headphone to the other ear on a TDH39 headphone is how much? This is the IA, correct? Okay. And it should be reaching till here, but to affect the other ear BC, we should be knowing the BC of the test ear in this case. Understood? So IA plus BC of the test ear. But do we know the BC of the test ear? No, we are finding it out. So as a convention, we take the BC of the non-test ear. So it is BC of the non-test ear. Yes, but it should not reach the enter into the other cochlea. So we do -5 so that it is kept away from the cochlea. So it should be -5. So now in this case, the IA would be 40 plus BC of the non-test ear is how much? 20 minus 5. So this is how much? 60 minus 5 is dB EML. So this is the maximum masking noise and this is the minimum masking noise, 45 dB and 55 dB. Understood? So this is how you find the minimum and the maximum masking noise for BC masking. Clear? Thank you.